Everyone, welcome to my video. Today we're just gonna be talking about scalars and vectors. So yeah, our channel, I'm gonna make math and physics actually make sense. So yeah, this is super important. So I'm just gonna circle it right now. Super important, by the way. So yeah, scalars and vectors. Sounds fancy, but don't worry. It's actually really simple. So, what are scalars and vectors? Let's start with the basics. Scalars and vectors are two types of quantities in physics and math. Scalars are just like the chilled, laid back numbers that don't care about direction. They just have magnitude. Examples of scalars: temperature, because 30 degrees Celsius doesn't point anywhere. Speed, like going 60 miles per hour, but not not saying where. And time, because no one says I have 5 minutes north. That doesn't make any sense, right? On the other hand, vectors are the dramatic ones. They need both magnitude and direction. So scalars, magnitude. Vectors, let me use a different color here. Both. Vectors, both. Gotta really memorize this. There's a lot of questions that ask, is this a scalars or vectors quantity in high school? So you need to know that vectors have both. Repeat it with me. Vectors have both. So anyway, yeah. So if you tell someone you're running at 10 miles per hour, they'll ask, but which way? That's what makes a vector. Examples: velocity, speed with direction; displacement, your actual movement from point A to B; and force, because if you push something, you're pushing it in a certain direction. Yeah. So let's just get to visualization here. I drew something here, right over here. Yeah, let me just circle this. So yeah, let's use a soccer ball to demonstrate. If I say I kicked the ball with 20 newtons of force, cool. But where is it going? That's just a scalar. But if I say I kicked it with 20 newtons to the right, boom, that's a vector. Vectors are represented by arrows, just like this right now. The length of arrows shows the magnitude, and direction of the arrows shows, well, the direction. Simple, right? So why does this matter? Imagine a GPS. If it only told you drive 10 miles, but didn't tell you which way, good luck getting anywhere. That's why displacement, a vector, is way more useful than distance, a scalar. Or imagine a weather report saying this wind is blowing at 20 miles per hour. Okay, but in which direction? Straight at me, or pushing me off my bike? That's why wind velocity is a vector. So quick recap, scalars are just numbers and magnitude only. Vectors are extra. They have both magnitude and direction. So this right here, this is a vector. Knowing the difference is super important in physics, sports, navigation, and even daily life. If you found this helpful, give it a thumbs up, hit the subscribe button, and comment below what's your favorite vector in real life. Mine's definitely wind velocity when it's helping me bike faster. See you next time. Thank you for listening. Have a wonderful day.